It's not gonna be enough. 2%. 2%. Upon returning from the moon, I found myself with a whole bunch of science to spend, a bunch of research points to unlock new science, tech, breakthrough things. So, looking forward to my plans on putting a colony or a rocket factory on the moon. First thing I need to do is I need some good scans. I need to know where the biomes are, and I need to know what concentration of the various materials they have inside them. So this is one of two satellites. This one's going to orbit Earth. Next one's going to orbit the moon. But it's going to give me a nice picture of where the biomes are and what concentration of materials are inside them. We're in Kodiak, Alaska again. It's my favorite spot to launch a rocket to polar orbit. So I've got two instruments, the first of which needs to be at least 673 kilometers high in a polar orbit to do its thing. And then we'll move up to a higher orbit for the multi-spectral scan that will take much longer. Space, I'm gonna cut the throttle, get rid of those fairings. Start the engine back up again. Get those antennas down. There's some cotton key to it. survey scanner. And here's the multispectral sensor. You'll notice I have a big battery. And that is necessary for this thing to transmit all its data. I'm not sure exactly what kind of formula it uses, but I think it has to do with the size of the Earth, because you don't need a big battery for the Moon. But for the Earth, it's going to use almost all of this electrical charge. I think I'll keep it at 400, then we'll ride it up to the apoapsis. On second thought, I'm a little worried about connection here, so let's drive it higher. Oh, I still got a connection. We'll put it right at the target altitude. 7 kilometers. That way, just maximize the possibility that we're going to have a clear line of sight on some sort of something we can communicate with. And I don't really need to be in this perfect of an orbit. I'm just being kind of anal, I guess. And of course it is going to change over time anyways, so. Good practice, I guess. Yeah, good practice. Okay, bad practice. Okay, so let's deploy the scanner. I'm going to wait till I get around in the sun just in case. My battery's plenty big enough to do this in the shadow, but I'm going to do it in the sun anyways, just to be safe, so we can have a source of electric charge coming in as we're doing this. Get these solar cells in the sun here, and I'm doing a horrible job at it. We'll get there. We'll get there someday. There we go. Good enough. There's some charge coming in. Perform orbital survey. See, it takes a while. It goes a lot faster when you're at a smaller body. And it is putting a dent already on this electric charge we have. And what we're doing now is we're scanning for the various resources. And it'll give us a nice little overlay map where we can look and see different hot spots on the planet for different resources. Now I think with the ScanSat mod you can turn this feature off because this is one of the stock scanners, and so it's not really intended to be used with ScanSat. But the issue I've run into is it doesn't really matter because, and I'll find out if this is true because I haven't, the last time I played it was in a different version, so this still may not be an issue, but I was getting the same concentration of ore everywhere in a biome, so it wasn't really using the resource maps. So we'll see if that's still true. So more than anything, I'm using this to get science. And I'll do the same on the moon too. So yeah, it does take a while. We're only 50% done. And then I'll move it up to a higher orbit. So 2,500 kilometers is the ideal orbit for the multispectral scanner. I would at least have to push it up to 10 kilometers. 10 kilometers? I don't know if I wrote this down right. 10 kilometers. Then I could be able to scan it from here. Well, we're going to shoot for the ideal orbit regardless. Yeah, that sounds right. 10 kilometers minimum. And if you don't have a big enough battery, it'll just cancel. So if you send a ship that doesn't have a big enough battery to do this and it runs out of electrical charge, it's just, it won't work. You can't use this scan. So so now I got 15 science from that, and yeah, I'll have enough electrical charge to send it back, I think. Yes, barely. So now we just need to push up our orbit to 2,500 kilometers. This way. Let's push it. So I don't know if you need to be over it or above it or what the tolerance is for this orbit, but so we'll just get it as close as we can. 58 minutes to Apoapsis. Yeah, it looks like one of the scanning modes is on. So you can check out different resources, see it on this map. You can pull out this map and look at it on here. Train if you know what you're doing, which I clearly don't. So, Earth, celestial body resource. Let's take a look at metallic ore, which is, it gives you various concentrations. There you go. And if you look at your cursor down here, it'll show you the concentration and percentages. Looks like 6% is about as good as it gets on the surface. Ooh, is that 9? Where is that? There's all kinds of 9%. The heck? I don't even think this heat map is really very indicative. Oh. Or am I reading it backwards? Okay, the blue is a higher concentration. I was thinking the green was a higher concentration. So the land is very poor in iron, or metal ore. Why the sea is very rich. It's interesting. So actually this Kerbal Space Center might be a good place for a mining operation. We could almost cut out the middlemen and make our own rockets. And I just passed it. So how do we turn this off? Toggle overlay. That'll do it. Okay. So we're coming up on our apoapsis, where we will circularize our orbit. Boom, boom, boom. To 2,500 or approximately. I'm getting close. And I should have plenty enough fuel to do it. Ooh, very nice. That was very lucky. Okay. We can just close this. It is no longer necessary. And ScanSat, it doesn't really matter where you point your spacecraft. So we can pretend that it's scanning the Earth, but it could be inside a, I don't know, could it be inside a cargo bay? I don't even know. But it can be facing in any direction and you can still scan with it. And this particular scan is probably going to take a while. Can I turn it off? Or... resources, yes, I think I can. Resource overlay, there we go. And now we can see the biomes. Biomes are being revealed. Okay. So, we just gotta let that circle and circle around. I didn't check to see if that was the ideal altitude, and to be honest, I'm not even sure what that does. I'm not even sure what ideal means. It's just like a thumbs up from the sensor. But it makes me feel much better to see it. Suboptimal does not give me warm fuzzies. So one thing kind of gotta look at is these little lines here. They tell us the next orbit around, it's just going to be a little teensy bit this way. Meaning it's going to be probably scanning the same area. But I'm not really too concerned for Earth. I don't really need to know exactly where the biomes is. It might be, I might have to take some trips pretty soon here to get collect the rest of the science. So we're going back to the Space Center. We've got 316 science still left to spend, even after I bought the tech for those scanners. And so the next launch we have is going to go to the moon. Alright, we're back in Cape Canaveral. This time we've got a much bigger rocket. Same scientific instruments. This time we're going to the moon. So we need a lot more Delta V. Again, we're back in Cape Canaveral. Launching into the lunar plane of orbit. This rocket isn't that much different than the other one. It's just a lot bigger in the rear area, in the lower area, in the bottom. My relative inclination up here because I use it so much since we're going to be going to the moon. So instead of having that big honking window open every time, I'm going to put it in this nice handy dandy flight engineer HUD. It's hard to see it as I'm here. When you're in the dark, that's quite appropriate. That was a little early. That's okay, we're close enough to space now. Doesn't really matter. Now we're in space. I actually remembered to hook up my action groups. Now I got my antenna out. And our apoapsis is way too. I wasn't paying attention, and I pushed my apoapsis up to 319 kilometers. Very, very amateurish of me. I've got a much smaller battery in this one. Did I pass my apoapsis? Did I go shooting past it? I think I did. Oh dear me. Just want to adjust the orbit a little bit here. This is not the best use of fuel here, but I don't want to push my apoapsis even bigger. Oh, I'm 0.2 degrees off. Okay. So we're in orbit. I guess it doesn't really matter that I'm a little off on my orbit because I'm going to be launching into a polar orbit of the moon. So if I'm exactly in the plane, that's just going to mean that my my course correction is going to have to be more significant. So let's get that out of the way. Get Principia out here. Let's do some flight planning to get us to the moon. So what am I doing here? I want to switch to a moon-centered, non-rotating reference. Come out here. I'm going to need about 3,000 delta V. My steps here. No, I have to increase this. I only did it for one day. It's interesting. Nearly enough delta V. And so I'm going to swing this back and forth to get the lowest paraapsis I can here of the moon. Just eyeball it. Psst. And I'm adjusting the time of the burn. Trying to find the perfect times to use the least amount of delta V. Then we'll use a little bit more delta V. And again, we'll adjust to get it the timing right to get the most bang from a buck. And we're going to set a collision course this time. Because about halfway through we're going to have to do a binormal thrust. Binormal burn to put us into a polar orbit. So that's pretty good. Click show on nav ball. Got 20 minutes to do this burn. Requires 3090 delta V. I have 5,200, so that's plenty. Plenty. Let's go ahead and move forward. 10. And I did learn something about Principia that I didn't know before. Well, that I probably should have known if I would actually read what's out there. So this counts down to the ignition. 34 seconds. Because I was having problems with it disappearing, and of course I was too busy looking at my burn because I don't really practice. I just kind of learn as I do. That's the Kerbal way. But this ignition will switch to I think cutoff, and it'll give you a countdown of how long your burn's supposed to last. But something like this, you want to cut it off early so you can do some fine tuning. Because if you don't get it just right, then your orbit's gonna be way off. So, and you're just gonna end up wasting delta V. So you want to start exactly when that reaches 0. So I got 45 seconds. And this is where you adjust to get right on the maneuver indicator, the little blue bracket on the nav ball. Watch the timer come down. We can also watch the pink orbit. That's your live orbit indicator. That's where you are going to go. The dashed line is your planned orbit. So 10 seconds, cut off at 9 seconds. 8, 7, 6, 5, 3, 2, 1. So I'm going to cut it off right there. And see, that's when your maneuver node disappears, is right when you reach, when you exceed the cutoff time. And so we got most of the work done. So if we just do this, this isn't going to change. This isn't going to have a major change to our actual orbit. So see, we can pretty much match it up, even though we cut it off early. So now we don't need that anymore. Can delete my flight plan, and we're on our way away from the Earth. Can't really tell by looking here. So now we need to plan another maneuver. This time to put it over the pole. And the moon is, its axis is tilted compared to its orbit. It does have an axial tilt. So, but, and the problem is there's no indicator of where the pole is. So how do you decide where a polar orbit is? Well, luckily, when you try to map these planets, that it gets really distorted at the poles. So you can tell right there that that's where the pole is. In fact, if you drive there, or if you put a lander there, on a lot of these places they have these super tall little spires at the poles, which is a little immersion breaking, but kind of funny too. And there's one down here too. Alright, so let's plot a new maneuver. So hit create flight plan. This extends the lengths of the dashed lines. So you see it creeping forward. That's our planned course. So you want to add a maneuver. So this is where we start our burn. You can see it by the little colored lines here where that's going to be. I just eyeball it. I want it about halfway there. Probably not the most efficient, but I'm not counting. I'm not down to the 1 or 2 meter per second accuracy here. I've got plenty of fuel to work with. So, and then we'll do some binormal thrusting, and we can kind of tell that this is see that we're way off the pole here. And my target altitude, so I want to do that multispectral scan first. No, I want to do the other one. Actually, the multispectral scan is more important, but the other one's faster. So we'll do it. We'll do I think max I can perform that scan is 1,500 kilometers. So we'll shoot for around 1,400 kilometers as a parabosis we'll shoot for. So that's 1 million. No, it's not. That's 1,000. 1,000 kilometers, 1,000,000 meters. So we actually want to be a little bigger than that. But yeah, it has to be a polar orbit to initiate that scan. Not only to initiate the scan, but it's just a good idea to meet a polar orbit when you're doing the ScanSat stuff. Otherwise, you're not going to be scanning the poles, which I seriously doubt I'm going to be putting my colony there. So we need to change the tangent, and that should move us over the pole. And I'm not sure what the tolerance is for that, how far off the pole you can be before it disallows you to make that scan. And one thing you don't have to worry about in stock Kerbal Space Program, but you do have to worry about in Principia is how far away from the moon can you orbit and possibly in the future sometime no longer be orbiting the moon. Whereas in stock Kerbal you have this nice sphere of influence where if you're inside of it, if your parabosis and your apoapsis is inside of it, then you're going to stay inside the moon's sphere of influence. You don't have to worry about popping out. This one, if you don't pay attention, your thing that's in orbit could drift out of orbit. But I think I'm close enough to it that I don't have to worry about it at this. And I guess you could project in Principia and see where your orbit's going to go and project it far into the future if you want. 13. Yeah, I need to be under 1,500 kilometers. And we seem to have achieved the plan. So we're going to start fast forwarding. Watch the Earth recede. So this one we don't have to worry so much because about getting the timing right, just by virtue of we're not very close to a gravitational body, and so if we start this burn late, it's not a big deal. I show a duration of 0.2 seconds, and we definitely don't want to do it that fast. So we're just going to do it nice and slow. If I had RCS, I might even use RCS to do this. I got the wrong one. Darn it. Hopefully I didn't get too low. Ooh, that's very close. Because I can't be over, that's the maximum altitude. Hopefully I don't have to go back down. That would be a tremendous waste of fuel. Alright, so I got my lunar orbit locked in. Interesting. Time to Parapsis. Got time to Parapsis 3 days, 18 hours, 14 minutes, but this says 9 days, 12 hours, 25 minutes. Interesting. So where's the moon? Sun. More sun. Okay. Tiding. Okay, where is it relative to the sun? Oh, no wonder. So I have to look pretty much exactly into the sun to see it. So there it is. Right there. The last thing we want to do is fly right by it. And that's precisely something that I would do. Oh, I guess it will give us a warning when you switch spheres of influence. It will kind of change your camera up a little bit. So we'll be a little reckless here. CFR 17 hours. See if this Parapsis is more accurate now. 17 hours. Okay, I think we were getting a Earth Parapsis last time, and so it has to switch to the Moon sphere of influence to give you the correct Parapsis time for the Moon. And I'm not going to plot this burn. It's just you just point the ship retrograde at the Parapsis and burn until you get a circular orbit. I don't really need a maneuver node to do that. let's get it a little further under. Because things change a little bit. So, we should be there. Under 1,500 kilometers, so we should be able to perform this here resource scan. So let's deploy the scanner. We've got full electric charge. I even got some sunlight going on here. Maybe we should rotate to get a little better view. Get this thing pointed at the sun. There we go. And perform orbital survey. See, this one goes a lot faster. And it's going to use a lot less electrical charge. So same deal with the last mission. We do the scan, transmit the science, then bump it up to a higher orbit, 2,500 kilometers. Uh-oh. Are we going to have enough electrical charge? That would be very sad if I don't. Oh no, it's not looking good. It is not looking good. No, shoot. Okay, that was a huge miscalculation on my part right there. Oh God. Alright, I'm not sure how I'm gonna get out of this one. I can shut down one of these maybe. Let's see if I can save a little bit of. So that didn't save me any electricity. I don't have SAS on. And that's not going to make any difference. That's not helping. Maybe I can. Here, let's turn this on. 50. I can get slightly better by orienting it with the sun. I can get 50. Charging at 50. I don't think that's going to make that big of a difference. Let's try it. Let it recharge back up. We'll probably just have to go all the way around. Okay, so we're fully charged here, and we've got line of sight. Who are we? We're bouncing it off somebody. I don't want to put the other antenna in, and I won't even have range. We'll try this one more time. 15:30 halfway through for this to work. Oh, this is gonna be close. Why didn't I have a better safety margin? Oh, it's not gonna be enough. 2%. 2%. Oh, that's very disappointing. Oh, what a waste. Alright, so we're just going to boost it up to our target altitude. So, going 2,500. I wonder. How much delta V do I have? I kind of wonder if the orbit, has an impact on how much electrical charge it takes. I'm curious. But I don't want to test that. We're just gonna boost up. We'll boost it up. Get that multispectral scan. That'll be good enough. That's what I really need anyways. I need to know the boundaries for the biomes so that when I start landing, I can plan accordingly and not have to guess where the biome is, so I can hit it, take my measurements, get my science, and go back up without being redundant, without landing in the same biome multiple times. And that's what this scan should get me over time. And I need to boost up to 2,500 kilometers, a circular orbit. So now we can close this little guy. We can get it to work. See, it'll tell us 174. Interesting, that's different. Different than Earth. And get our multispectral scan started. And let's get it pointed at an orientation where we can get some sunlight, because it's going to be like this for a while. and I can get this other antenna out. There we go. And let's check on this guy and see if we're performing our biome scan. Yes, we can see the biomes populating already. Let's get the big map. Oh, that is a big map. And look! I guess our orbit wasn't as bad as I thought it was. It's already gave me all my biomes. There's the mountains there. There's some mountains there too. That's what I had so much trouble getting last time. Mountains. Would have been nice to know where they are. I think there's like a Vandenberg. That's closer here. I was gonna try up here in Kodiak to go north and get some mountains. So good thing I didn't do that. That would have been bad. What is this? Shores. Oh, shores. Oh, moon. I want to look at the moon. There we go. Biomes. That doesn't seem like too bad of an orbit. Although I think it's going to take it a month to go all the way around. So, not optimal. Big mistake on my part. 2% off on my electrical current reserves. Sad day for Kerbal, whatever Kerbal engineer designed that. But we achieved the big major goal of this flight, which was to get that biome information, that biome map. We're well on our way, as long as nothing bad happens.